Hi students, now we are going to solve the numerical problem number 6. If 10 power 20 oxygen molecules per second strike 4 centimeters square of a wall at an angle of 30 degree with the normal, when moving at a speed of 2 into 10 power 3 meter per second, find the pressure exerted on the wall. Given mass of one oxygen atom is 2.67 into 10 power minus 27 kilogram. Okay students. So what is the problem given? I have represented diagrammatically. Oxygen molecule is diatomic. So two oxygen atoms combine together to form an oxygen molecule. Actually, how many number of oxygen molecules are going to collide on the wall is 10 power 20. But I will take only one molecule at a time and then I will multiply by the total number of oxygen molecules. You can see the picture here. So one oxygen molecule having a mass m and speed v, so that its momentum is mv. It is moving along a straight line. It falls on the wall, okay, at a point O, such that it makes angle 30 degree with the normal to the wall. Then after collision it undergoes elastic collision, so at the same angle it is coming out, that makes 30 degree with the normal after collision also, so that its momentum after collision is mv in this direction. Okay, now before collision its momentum mv is resolved into two components. So one component of this mv is acting towards the wall, okay, that is P initial along the normal. Okay, so this is along the normal, it is equal to what? mv into cos of the angle theta. So mv into cos 30. So this is acting from N towards O. And another component here, another component will be acting in this direction, and that is mv into sine 30, mv into sine of 30. That is in the downward direction towards O. Now after collision on the wall, once again it is coming out with the same momentum at the same angle 30 degree with the normal. That also is now resolved into two components. So after collision you can see the direction of motion of the molecule. So one component will be from O to N. So that is P final. So P final along the normal is equal to once again mv into cos of theta, but the direction is opposite to this. Only the magnitude I have written. Magnitude I have written. If you want, you can introduce a minus sign to indicate the direction also. So it is minus of mv cos 30. Okay. Then another component is downward. Again it is a downward. So this also is what? mv into sine 30. Now along the horizontal direction, what is the change in momentum? That is very important for us. So because another component is along the wall, along the length of the wall, so no pressure will be exhibited, or these two components of momentum do not contribute to the pressure. Only the component which is perpendicular to the wall, the perpendicular component, okay, the component of the change in momentum perpendicular to the wall only can exert a pressure. Understand? So we need these two components only. So I will write the change in momentum, okay, the change in momentum along the normal. The change in momentum along the x-axis is given by delta small p. So that is equal to P final minus P initial. So what is the final momentum along the normal is minus mv cos 30. So this is minus mv into cos of 30. Then we have to subtract minus of what? P initial. P initial is again mv into cos of 30. So that this is equal to minus of 2 mv into cos of 30. So what is the magnitude only is required for us. Magnitude is modulus. Modulus of the change in momentum is what? 2 mv into cos of 30 degree. Okay. Now what is given? The oxygen molecules per second they are striking the wall. They are striking per second. Per second means delta T is equal to 1 second. So delta T is equal to 1 second. Okay. So this change in momentum divided by the time taken will give you rate of change of momentum. Understand? So rate of change of momentum, rate of change of momentum P is nothing but force. So force is equal to delta P divided by delta T. So this is equal to what? 2 mv cos 30. 2 mv cos 30 divided by 1. Divided by 1 remains the same. Is it not? So this is now equal to 2 into mass of oxygen molecule, is it not? Now it is given in the problem, mass of one oxygen atom is 2.67 into 10 power minus 27 kg. Therefore, what should be the mass of an oxygen molecule? So mass of oxygen molecule must be equal to twice the mass of one atom. So 2 into 2.67 into 10 power minus 27. Because there are two atoms of oxygen in a molecule of oxygen, therefore it is twice the mass of a single atom. So 2 into m, mass of one molecule, into the velocity is given as 2 into 10 power 3 into cos 30 is how much? Root 3 by 2. Cos 30 is what? Root 3 by 2. So this is rate of change of momentum, which is nothing but equal to what? The force exerted by the oxygen molecule on the wall along the normal or perpendicular to the wall. So this 2 and this 2 can be cancelled. So that this is equal to 2 into 2.67. Okay, so this is 2 into 2. This 2 into 2 is 4. So 4 into 2.67 into root 3 is 1.732. Okay, so 2 into 2 is 4 into 2.67 into root 3 is 1.732 into 10 power 3 and minus 27. So this is 10 power minus 24. This is here 27, here 3. Minus 27 and 3 will make the power as minus 24. So this is in Newton. Let it be as it is. Afterwards, we will find out the pressure. So this is the force exerted. Okay, so this is equal to the force exerted by the oxygen molecule. So force exerted by O2 molecule. Now the area of cross section, on how much area is the molecule? This is a force exerted by only one molecule, is it not? One molecule I am finding first. So this is the force exerted by O2 molecule, that is one molecule of oxygen. Afterwards, how many molecules I should consider is 10 power 20 at the last step. Understand? So the force exerted by one oxygen molecule is this much. On how much area it is impinging is given as 4 centimeter square. So this is 4 centimeter square. So this is 4 into 10 power minus 2 meter the whole square. 4 into 10 power minus 2 meter the whole square. So this is equal to 4 into 10 power minus 4 meter square. So centimeter square I have converted into meter square. Understand that? So now pressure exerted by one oxygen molecule, so is equal to F by A. Okay, so that this is equal to 4 into 2.67 into 1.732 into 10 power minus 24 divided by area is how much? 4 into 10 power minus 4. So 4 into 10 to the power of minus 4. So now you can cancel this factor 4 and 4. Then here 10 power minus 24 this will go up as 10 power plus 4, okay. So that this is now equal to what? This is now equal to 2.67 into 1.732 into 10 power minus 20. So this is the pressure exerted by only one oxygen molecule, is it not? Therefore, what is the total pressure exerted by 10 power 20 molecules? You have to multiply this by 10 power 20. Understand? So total pressure, okay, total pressure exerted, total pressure by 10 power 20 molecules, 10 power 20 molecules is capital P equal to 10 power 20 into 2.67 into 1.732 into 10 power minus 20. So 10 power plus 20 multiplied by 10 power minus 20, it will be 1. So I can cancel these two. Therefore pressure is now equal to 2.67 into 1.732. So I have to multiply these two numbers. So I am going to use a calculator. Understand? So we have to multiply now 2.67. 2.6. Okay, 2.67 into 1.732. So multiplied by 1.732. So this is found to be 4.624. This is coming as 4.624 Newton per meter square. So this is the expected final answer. Now first you have to understand the problem, then you have to make a list of whatever quantities are given in the problem and draw the relevant diagram so that you can deal the problem easily. So here actually you have to start with the schematic diagram, rough diagram like this, so that you should understand that one oxygen molecule is made up of two oxygen atoms first of all, and then its mass is taken as m, speed is v. So its momentum before collision is mv, and it makes 30 degree with the normal to the wall. So we resolve the momentum into two components, one along the normal and the other one along the wall. So with the same momentum mv, it is rebound at the same angle theta away from the wall. Understand? So after collision also I will resolve the components, horizontal component along this normal and vertical component along this wall. Now these two components of the momentum does not contribute to the pressure, is it not? The molecule exerts pressure perpendicular to the wall. That is why the other two components we don't consider. So its change in momentum along the x-axis only must be considered. Okay, I hope you must have understood this. Then after that, the change in momentum by time will give you the force exerted. Force exerted by one molecule I am finding first. And then pressure exerted by one molecule I will find. Force by area is the pressure. Later I will multiply with the total number of oxygen molecules, and this is the pressure exerted by the oxygen molecules on the wall is 4.624 Newton per meter square. I hope you must have understood well. Fine.